Hello students, welcome to our astronomy class. We are going to study all about the Earth's movement. There are 6 Earth movements we need to know about. Rotation, Earth rotates on its axis every day, 24 hours. Orbit, Earth orbit around the Sun every year, 365.25 days. Tilt, Earth tilt 23.5 degrees. Ellipticity, Earth orbits around the Sun in ellipse shape. Barycenter, Earth gets lunar gravity, vice versa. Precession, Earth's axis wobble with a period of 26,000 years. In this lecture, we will study Earth's rotation first. Please look at the Earth, all about Earth. Earth rotates itself on its axis every day, 24 hours. If you are outside of the Earth, looking down the Earth, then Earth turns counterclockwise. This is the top view above the Earth. Now you are on Earth. Let's look at the direction of the north, south, west, east. Then Earth rotates from west toward to the east. This is the view on Earth. This is the real world. Earth rotates counterclockwise from the North Star. At the same time, Earth rotates from west to east on Earth. The Sun does not move at all. Earth moves. However, from our point of view, we do not feel Earth move. Instead, the Sun appears to move. Earth rotates from west to east. That is why Sun appears to move from east to west. Sun appears to rise from the east and set to west due to the Earth's rotation. Now let's look at the stars. Again, who is moving? Only Earth. Earth rotates counterclockwise from the North Star. At the same time, Earth rotates from west to east on Earth. The stars do not move at all. In the real world, Earth moves. However, from our point of view, we do not feel Earth move. Instead, the stars appear to move. Earth rotates from west to east. That is why stars appear to move from east to west. Stars appear to rise from the east and set to the west due to Earth's rotation. From our point of view, stars seem to move around us every day. As viewed from above the North Pole, Earth rotates counterclockwise on its axis. Earth rotates from west to east. That is why Sun rises from east to west. Stars rise from east to west. One rotation takes 24 hours, basis for our day, solar day. Here are the Sun, the Earth, a girl, and a tree. The black dot in the middle of the Earth is the North Pole. We will study about the solar day and sidereal day. What about this single rotation? Here is one full rotation. Is this one day for us? 24 hours? No, this is not. This is not real. Earth rotates on its axis, but at the same time Earth rotates around the Sun. We will study Earth orbiting around the Sun next time. Earth rotates on its axis and orbits around the Sun at the same time. When you look at this drawing, what time is it for the girl? The Sun is over her head. Her time is 12 o'clock at noon. This is a real movement. This is one full single rotation, but it takes 23 hours 56 minutes and her time is not 12 o'clock noon yet. Earth needs to turn a bit more. Earth orbits around the Sun in 365 days for a one full cycle of 360 degrees. So we can say about 1 degree a day for Earth orbiting around the Sun. So Earth rotates itself for 24 hours. One cycle for one full rotation takes about 24 hours, exactly 23 hours 56 minutes though, with 360 degrees. Then we can get 1 degree of rotation may take about 4 minutes. Rotating Earth moves approximately 1 degree around the Sun each day, therefore needs to turn more than 1 extra degree to get the Sun overhead in the same spot. Now it is at noon again. One solar day, it takes 4 more minutes to go. One solar day equals 23 hours 56 minutes plus an extra 4 minutes to be the same time for the girl. For her, one day is 24 hours. Solar day relative to the sun, 24 hours. Sidereal day relative to the star, 23 hours 56 minutes. Solar day movement relative to the sun. Once one solar day is the time taken for the sun to return directly overhead noon. Sidereal day, the movement relative to a distant star. Here we get the straight a starlight parallel. At the time 1, the sun and a far off distant star are both overhead. At time 2, the planet has rotated 360 degrees and the distant star is overhead again. But it is not until a little later at time 3, after 365 degrees rotation, that the sun is overhead. Or 1 and 2 is a complete rotation of the Earth, but because of a revolution around the sun affects the angle at which the sun is seen from the Earth. 1 and 3 is how long it takes for noon to return. Our Earth is rotating all the time. Depending on the location of the Earth, the speed changes because of the shape of the Earth's sphere, ball shape. Where on Earth can you feel dizzy for the speed of Earth's rotations? Thank you very much.